Thank you very much. Let me share my screen and give me a second that I need to find the new screen. And is this one? Yeah. Could you see my screen right now?
Yes, we can.
Okay. Thank you very much. Well, very good morning or very good afternoon, depending where you are located. And thank you very much for sharing time with me and allow me to share some of my experience. And the topic today is reaching net zero by minimizing the operativity risks. Challenges and possible solution for the GB system. As you must be aware, I am located here at Exeter in southwest England. And of course, we are doing research in order to enable reaching the target of net zero emissions in the UK by 2050. Um, and today, the presentation will be quite short, and I would like to start talking about the four different documents that they are publicly available and presented are created by National Grid Electricity System Operator. National Grid Electricity System Operator is basically the system operator of the power grid, the transmission grid in the Great Britain. And there are four different documents that they are extremely helpful. The first one is the future energy scenarios that represent the different credible way to reach a decarbonized energy system with the target of 2050. And the second very important document is the operativity strategy report that basically explains the challenges in operating the system in this transition to reaching the net zero by 2050. There is another additional document that is the pathway to 2030 that is basically a holistic network design in order to reach this target for 2030. And yesterday, 7th of July 2022, National Grid released another very important document that is called the Pathway to 2030. Okay, today my presentation will be regarded basically to the challenges related to the operation of a network like the GB system with a massive penetration of low carbon technologies. And before I start, I would like to place you in a context. I must be honest, yesterday I was talking about the electricity intensity in the UK, and in 1990s, 65% of the generation was coming from something that was not environmentally friendly, was basically coal. And to be honest, in recent time, the carbon intensities have been reduced a lot, almost 50% reduction since 1990s. To be honest, right now, Great Britain is one of the fastest decarbonizing electricity system around the world. And if you look over here, the footprint, the carbon footprint of the UK has been decreasing a lot. And there are several moments in the time that has been extraordinarily important. In 13th of February 2021, we reached around 70 gigawatts of wind power generation. And in 20 of April 2020, we reached around 9.6 megawatts coming from solar wind power. And what is extremely important is that the carbon intensity for the GB system reached a minimum of 39 grams of CO2 per kilowatt hour of electricity on 5th of April 2021. And let me explain why this number is very important. Because National Grid Transmission Electricity System Operator, we are measuring the carbon operativity using a very specific indicator. National Grid defined the zero carbon operativity as indicator that is the ratio between the zero carbon transmission connected to the generation and the total transmission connected generation. And in that case, 5th of April 2021 is extremely important because at that moment we reach 84.6% of the transmission the generation coming from zero carbon energy. That means that we have been some moments during the day that we are reaching almost 20% less than the zero net target. The document that I was talking at the very beginning, future scenarios, defined four different scenarios of the penetration of low carbon technologies and also the forecasting of the demand inside the GB system. There is a scenario that is called the steady progression. The steady progression probably is the sad scenario because that scenario say that we will not reach the zero net by 2025. In fact, in 2025 will be around 243 million tons of CO2 equivalent emission. And but the other three scenarios that we are considering, they are extremely good. The scenario that is called system transformation, that we are increasing the penetration of hydrogen for heating and more active participation of the customer, and also the customer transformation scenario and leading the way, they create conditions where in reality the annual net emission will be negative. That means, for instance, that the scenario that is called here leading the way, that is the fastest credible decarbonization in the GB system, will reach a moment that we will be removing CO2 from the atmosphere. Okay. However, what is the big question here, and why I am talking to you? Because there is a big question, and that is my main research question. How do we deliver secure and resilient operation of the net zero GB system? And in that question, I believe that the answer for that is four different components. I believe that to deliver a secure and resilient operation of a net zero system, we need to take the advantage of four different components. One of them is the decarbonization, the decentralization, the digitalization, and of course the democratization. That is what I have been calling the four different Ds. Okay, and it's already identified that using those technology we can make progress on delivering the net zero GB system, coping with four different challenges that there has been already identified. What are the main operating challenges when we are talking about reaching net zero 2050 for the GB system? Well, National Grid Electricity System Operator has identified four very important elements. To be honest, there are five, but in this presentation, I will tell you only about four. The very important four challenges are defined for frequency, stability, voltage, and thermal. And the fifth one that I didn't include in this slide is restoration. Because for me, I try to avoid restoration, and if I am able to deliver a secure and resilient system, restoration will be not necessarily a very important point for my components. Okay. Well, but now the question is, can we solve problems or challenges related with frequency, stability, voltage, and thermal using these four different aspects: decarbonization, decentralization, digitalization, and democratization? Well, before I answer the question if we can do it, I would like to tell you four different components inside those elements. Well, decarbonization is something that is happening. Decarbonization represents the penetration of novel technologies that they are reducing the CO2 emission, and that include the penetration of generation technologies like the solar PV system and the wind power. However, what is important here is that we need to take into consideration that a huge part of this decarbonization can come from the demand side. The classical customer is changing the pattern and is changing the behavior and is engaging more and more with the electricity system and is engaged as prosumer. Right now, there are many customers here in the GB system that they are installing PV system, and some of them also including battery energy storage behind the meter, and they can participate in providing services to the grid. However, a very interesting point here is that we need to have the economic path, I mean the market that allow this participation and also allow the compensation of these kind of prosumers. From the decentralization point of view, I will say that this is connected also with this tendency of distribute energy resources installed at the distribution system. We are talking about that the future electricity system will be fully decentralized. And hopefully, with the help of the digitalization, we will be able to create an autonomous system. That means that the system will be able to self-healing and restoring in autonomous way. Also, the decentralization means that the role of the transmission system operator and the distribution system operator must engage with the customer in more active way. That means including faster communication between the customer and all the other actors like the TSO and DSO, and also removing the boundaries between them. I'm not talking about just legal boundaries, I'm talking about also markets and also information flow between the different TSO and DCO. And finally, one of the important things that we need to take into consideration in this decentralization is the fact related with the power electronic converters. And power electronic converters, they believe they will be a very strong component inside the future energy system. Digitalization is a tool to allow delivering the secure and resilient operation. Data-driven methods together with real-time operation will allow the autonomous behavior, autonomous operation that we are looking forward. And finally, democratization is basically a relative new term in the electricity system. However, energy democracy, that is the proper name that we need to think about, is basically using the justice in order to share the ownership, for instance, of the distribute energy resources in a community. New concepts like the community solar farm, community wind energy will start to appear, and also the cooperation. Today, I don't have so much time. In fact, I have only 3 more minutes remaining, but I would like to tell you about one very specific target. And one of the very specific targets that I want to tell you is basically one of the challenges regarding operation, and probably my favorite one, and that is related with the frequency. Frequency is a very good indicator between the balance between generation and demand, and with renewable creating a massive changes on the generation, and with the demand with new technologies like electric vehicles, solar PV and generation and so on, the frequency is changing a lot, and we need to cope with those challenges providing solution. In the GB system there are basically two services: the frequency response, that is basically something automatic that is based on the measurement of the frequency and determining the appropriate changes of the active power. But also there is a service that is called frequency reserve, that is basically operated manually, and those reserves, of course, they have economic impact on the final price of electricity. The issue in the GB system is that as we are installing more renewables based on power electronic converters, for 2050 we are expecting that the decrease on the rotational inertia start to create several challenges. And one of those challenges is the increase on the size of the maximum in feed, because also we are interconnecting with another power system like continental Europe using HVDC system, and also the installation of huge power plants. For instance, for 2027, we are expecting that the maximum loss in feed will reach 1.8 megawatts, and that is consequence of this huge power plant that already my colleague Professor Crossley mentioned, Hinkley Point C. However, what we have done, and we are closing because I have 1 more minute, I would like to briefly show you something of the things that we have been doing. There are many technical solutions to cope with the variability of the frequency, and energy storage is one of the things that I am totally engaged as a possible solution for the variability of the frequency. In recent time, we have been developing controllers, but controllers to enable multi-energy storage system, because battery is not the only solution. There are also some other energy storage system with different density and intensity that they can allow and cope with the frequency variability. For instance, ultracapacitor and flywheel. In this paper that you can find the reference at the bottom of the slide, we have been using fuzzy logic controller to enable the enhanced frequency controller that is one of the possible services in the UK to provide this frequency control. And most recently, we have been using data-driven methods, especially we have been working with deep reinforcement learning-based controllers in order not just to deliver the service, but also taking care about how the assets behave over the time, try to save the life of those components. Well, I am 55 seconds above the time, but my closure is that for delivering a secure and resilient operation, we need to consider the 4D. And that is basically my message over here. We need to take advantages of the 4D, decarbonization, decentralization, digitalization, and also considering the customer as a cluster to provide services to the grid. That's all for my presentation. Thank you very much. I'm sorry, I am 24 seconds above the time. Thank you.